Good morning. Today I would like to talk about how we can arrive at the formula used on Lab 2, where it comes from. The formula we used was distance. Oh, that's a bad color. Let's go get a different color. Distance is the square root of d divided by, not distance, time. Time was the square root of distance over 490. Where does that formula come from? Toward the very end of chapter 2, and you should have gotten this in lecture Wednesday, distance of travel or motion is initial velocity times time plus half the acceleration times the square of the time. Now, in free fall motion, we can use this equation. But in free fall, we have the fact that the initial velocity is 0. When the initial velocity is 0, that initial velocity times time term disappears, and we have distance is 1/2 the acceleration times the square of the time. We can take this equation and solve it for time by multiplying both sides by 2 to get twice the distance equal to acceleration times time squared. Then divide both sides by acceleration. So 2 times the distance divided by acceleration equals the square of the time. Switching sides, so trading sides on the equation and taking the square root, we get that time is the square root of 2 times the distance divided by the acceleration. Now we have an equation solved for time that has a square root in it, but we have 2d over a, and we want to see, can we get d over 490? Quick sidebar. The acceleration due to gravity is 9.8 meters per second squared. If we converted this acceleration from meters per second to centimeters per second, that would require us to multiply by 100 to convert from meters to centimeters. So in centimeters per second squared, acceleration due to gravity is 980 centimeters per second. Substituting that in, we get the square root of 2d over 980 centimeters per second squared. Now 2 does divide 980, and 980 divided by 2 is precisely 490. And with units, 2d over 980 centimeters per second squared becomes d over 490 centimeters per second squared. The distance we used in Lab 2 was in centimeters, so the centimeters units would cancel, and when we divide centimeters by centimeters per second squared, that would give us a unit of seconds squared. When we take the square root of seconds squared, that would leave a unit of time. So that is how we arrive at the formula. I'm going to go ahead and circle the one that has the units of centimeters per second squared, which was not in the formula for time before.